this is part 5 of the sensorless FOC bring up chapter. In the previous video, we brought up the estimator in closed loop torque mode, and we confirmed that the handoff from open loop into estimator base control is stable. Now we're going to move into closed loop speed mode. In speed mode, this is where you command a target speed, and the controller automatically generates whatever torque current is needed to reach and hold that speed. In other words, the speed loop sits on top of the torque loop. A few things that changes from torque mode to speed mode is that in torque mode you directly commanded the IQ. However, in speed mode you are commanding the speed. And the firmware uses a speed PI controller to compute the IQ reference. So in speed mode, there's 3 main things you will need to set. First is the speed set point. Second is the speed ramp rate. And third is the speed PI gains, KP and KI. And again, just like we did in torque mode, we will use JScope in RTT mode to visualize stability between the speed reference and the speed feedback. Before we dive into speed mode, I want to make sure you have these things done. First, you will need to have the open loop align and go start smoothly and repeatedly. Second is having the estimator handoff be stable. Third is having the closed loop torque mode run smoothly. And then finally, make sure your motor parameters and limits, especially the speed limits, are reasonably accurate. Alright, so let's set the speed mode in the GUI. The first thing we need to do is enable the closed loop checkbox. Here is the GUI. Make sure this is selected. Then we will set the closed loop mode to speed mode. Switch to speed mode. Now for this, you want to make sure to leave ID ref CL to 0 for the tuning process. Next, we'll set the speed controller section, shown here, KP and KI for speed controller. We can use the initial speed PI controller gains, where we have the speed KP set to 0.01 and the speed KI set to 1. As for the closed loop speed ramp, we will match the open loop speed ramp. For my case, it will be 50. So let's go to controllers, 0.01 and 50. And again, we can always adjust the speed ramp if we want to get to the target speed a little faster. We will use JScope RTT mode for a live demo. And again, in RTT mode, we can only plot 4 channels. So I'll pick the most useful signals for speed loop tuning. In the FOC GUI debug DAC output 1, 2, and 3, you will select the following variables. First, you will select the speed reference. This is the commanded speed. Next is the speed feedback. This is the estimated speed. Next is the IQ reference. This is the torque current the speed PI is commanding. And then the IQ feedback. This is the actual IQ. Okay, so go ahead and click write all parameters, and we will then open JScope. Okay, so here we have JScope all set up. At first, I'll command a small speed target. So remember, for open loop, we are running at 26. Once it reaches this value, it will transition to closed loop, which now gives it a target of 50. We are ready to enable. Let's go ahead and play JScope. Let's zoom out to around 20 seconds per division so we can get a bigger scope. Go ahead and let's motor enable. So for this, we can see the red is the speed reference. You can see that as steps to the commanded value, and the speed feedback. Here, let's go ahead and stop. And the speed feedback will ramp towards it and then eventually meet it. As you can see here, we do see a bit of overshoot. We can fix this by adjusting the KP value. So for this, I will try and increase the 2.05. Let's go ahead and retry. Let's go to 20 seconds per division and let's click motor enable. So from here, we can see that it does reach the reference with minimal overshoot. The speed feedback follows the speed reference. And we can also try and testing it by adjusting the speed. So we can go to 100. As you can see, we can try and moving it down a bit. Okay, so again, we can do 150. It's much faster. So that is 150. And so from this, we are now having a better step response as compared to the original KP value. Again, you can always fine tune by adjusting the KP and KI. Here are some basic concepts of PI controllers and the tuning flow that I recommend. You start by increasing KP in small steps until the speed response feels tighter, which is exactly what we did in our demo. The motor should reach the target speed cleanly without taking forever to get there. Once KP is in a good spot, you can start adding KI. KI will remove the remaining steady state error by gradually increasing the torque command until the speed settles right on the set point. Here is a troubleshooting table giving you different scenarios on motor behaviors and possible reasons, as well as the recommended adjustment. And the best practice is to tune with J-scope running. You can try plotting the speed reference and the speed feedback along with the IQ reference and the IQ feedback. That way you can see both the speed response and the torque current the loop is demanding in real time. And that wraps up the video. That was closed loop speed mode initial bring up. Once the speed mode is stable, you can start pushing towards your real operating range, the higher speeds, faster ramps, and also you can verify under load condition.